All right, in this video, I'm going to go over examples 4 and 6 from lesson 2.4. So one thing here in example 4, there's a typo there. You want to get rid of that little I that's right there. That's not supposed to be there. All right, so we have 10 over 2 minus I. And our goal here is to try to get the I out of the denominator. We're working with the quotient with complex numbers. And the strategy that we'll incorporate is we'll multiply the top and bottom by the conjugate of the denominator. So if we multiply top and bottom by 2 plus I, here's what's going to happen. The numerator will be 20 plus 10I by the distributive property. In the denominator, you're going to have 2 times 2, which is 4. The outside will give you a positive 2i, and the inside multiplication will give you a minus 2i, and those will cancel because they're opposites. So multiplying by the conjugate will achieve the goal of getting rid of the I from the denominator. We cannot have I in the denominator of a fraction. That's the main idea here. Because it doesn't really make sense to divide things into I groups. So that's sort of the main idea. So, let's finish the problem now. We did the first, we did the outside, inside. Now we have to do negative I times positive I, which is negative I squared. And we still have an I in the denominator, but it's being squared. And we know that we can replace an I squared with negative 1. So while our numerator has the 20 plus 10i, the denominator has 4 minus negative 1, which is 4 plus 1, or 5. So our goal of getting the I away from the denominator has been achieved because now that denominator is just 5. Finally, we're going to finish the problem by taking the denominator 5, and we're going to apply this rule over here that I'm writing. If you have an a plus bi and you divide both of them by c, what you can see here is we can divide each of those a and b, we can divide each of them by that denominator c. So I'm going to take 20 and divide it by 5 and get 4. Then I'm going to take the 10 and divide it by 5 and get 2i. This will be my final answer, 4 plus 2i. So I want you to do the 2 try-it problems here and here. And go ahead and work through them on your own. And by the time you get to the end, you should get to the solutions. And the solutions are, for A, you should get 4 plus 12i. And for B, you should get negative 2 minus I. Now I'm going to go right to example 6. So we have them on the same video. We're going to solve the problems on this page not by factoring, but by solving for x the traditional way. So first, we're going to take away 4 from both sides. Then we're going to square root both sides. And we get x equals. Anytime we're square rooting an x squared equation, we want plus or minus to be in our answer, positive or negative. And now we have the square root of negative 4. And before we learned about I, the imaginary number unit, you probably would have just left this one blank and said there's no solution. But now we know that the square root of negative 4 is 2i. So that's my solution. Those are my 2 solutions, positive or negative 2i. This problem over here is done in a pretty similar manner. We're going to subtract the 49 from both sides, square root both sides, and we get x equals plus or minus 7i, because the square root of 49 is 7. Since it's negative, you put the I next to it, it's 7i. And finally, we're going to take away 25 from both sides. Divide both sides by 9 before you take the square root. Do not change this to a decimal. Leave it as a fraction, please. especially since the numerator and denominator are both perfect squares. It's not too bad square rooting -25/9, because you can square root the numerator and get 5, and square root the denominator and get 3. And since it's negative, you're just going to put the I next to the fraction for your answer to try it 6B.